Tangent.
Your internet is unstable. क्या हो गया, क्या रहेगा?
कनेक्टेड उसमें जाके डालो सबको प्लीज डाउनलोड
Online participants, if I am audible, then kindly consider that the data set is shared with you through Google Mail as well as through Telegram link. You can download it as hands-on practice will go on with simultaneously presentation. Participants कृपया ध्यान दें, ऑनलाइन पार्टिसिपेंट्स आप लोगों के साथ डेटा और टेलीग्राम ग्रुप पे और जीमेल पे शेयर कर दिया गया है, उसको डाउनलोड कर लीजिए। हैंड्स ऑन प्रैक्टिस प्रेजेंटेशन के साथ साथ होगी।
अच्छा एक चीज और, जिन लोगों के पास सिस्टम नहीं है और कोई लिंक शेयर है,
लिंक दोनों ग्रुप पे शेयर है टेलीग्राम।
लैपटॉप किसके पास नहीं है? आप लैब में बैठ ऑल डन हो तो अभी हम बुला रहे हैं।
ये क्या ये कहाँ लगाना है? कहीं भी
So we are going to session for this. And I would like to whole introduction. And without any further ado,
Thank you. Let us welcome yes. Sanjay, childhood friend of mine also, and apart from technical difference, Sanjay sir is, in the area of and experience of dealing with projects as well as different activities related to application. Let us welcome.
Thank you. Thank you. Thank you, sir. It's an honor to be teaching in your alma mater, a product of Lucknow University. Teaching, I used to study in UG classes in this room itself. The very introduction of arts in the BSc first year happened in this room. So, what a nice coincidence that as a resource person, I'm standing here in the same room and delivering a talk. So, without wasting our time, I think let's move in. I've been asked to deliver the talk on two areas. One is your logistic regression, and the other one is your exploratory factor analysis. Now, before I start off, logistic regression. I hope linear regression has been slightly discussed in yesterday's class. So, let's understand one simple thing. Regression depends upon your dependent variable, right? अरे हाँ या ना जी अगर हम लोग आपस में बात करेंगे तो ज्यादा अच्छा लगेगा I don't want a monologue to happen, right? So हो गया हो गया हाँ My mic off? हाँ. So your Y dependent I hope we understand that the dependent variable is measured on 4 different scales. Your nominal scale, your ordinal scale, your interval scale, and ratio scale. These are the 4 scales on which your dependent variable is measured. And depending upon the scale of measurement, the regression techniques are applied. I hope this much we are aware of. Now, if the dependent variable is measured on the nominal scale, that is categorical scale, then the two forecasting techniques which we generally use is logistic regression, that's one. अब भाई हमारे statistics वालों दूसरी, what is the technique we use? The other concept which we generally use for categorical forecasting is your discriminant analysis. Like linear discriminant LDA, Lucknow Development Authority. linear discriminant analysis. So these are the two basic techniques which we use for the dependent variable which is on the categorical scale. If you have your dependent variable on the ordinal scale, then the concept which is used is called ordinal regression. Then the concept is used which is used is called ordinal regression. Whereas if you have it on the metric scale, that is either interval or ratio, then the forecasting technique which we use is your linear regression analysis. So this is the broad classification as to, depending upon the variable as you measure on the scale, you have either logistic regression, or you have ordinal regression, or you have linear regression analysis. This is the broad classification. Now, logistic regression belongs to a family of qualitative response models. It belongs to qualitative response models. Logistic regression is also called logit. We also have probit, right? We also had togit. So all this belongs to the family of qualitative response models. The basic differences is, as we move from one to another, we tend to use probability. In regression, we use what? OLS, GLS. यही use करते थे ना, ordinary least squares, generalized least squares. Whereas in qualitative response models, generally we go ahead with maximum likelihood method of estimation. We go ahead with maximum likelihood method of estimation. So that's the basic difference. In case you have any, one more thing. ओ यहाँ पर बैठ करके सिर्फ प्रवचन मत सुनिएगा. It will be better if you keep on posing questions, because it is these questions which will help you in better understanding. ठीक है ना? Please do ask questions. जितने questions पूछेंगे, it will be good, because the class will be more on a dialogue basis. So now, if I go by logistic regression, अभी तक कोई सवाल? Any issue in terms of understanding the technique? Which technique to be used where? Now, you can see here, I have tried to give you a brief as to how we use it. When our response, that is the dependent variable, is continuous, you have the linear regression. When it is categorical, that is on the nominal scale, you have the logistic regression or logit. Again, logistic regression, it uses the categorical predictor values. Now, how do I code the category? It could be, here you have x equal to 0, and here you have x equal to 1. Oh, sorry, y equal to 0 and y equal to 1. Yeah, you have to. ये क्या बात है? ये क्यों कर रहा है? इसकी वजह से मूव कर रहा है. टच करना पड़ता है इसको पहले इरेज कर दें. नीचे जा रहा है पेन पेन हो जाएगी. We have two categories. If it's a two category model, you have two categories, y equal to 0 and y equal to 1. Now, for example, the best example could be, if I assume you to be the students in the class and my variable is intention to study in the class. My variable is intention to study in the class, that's the variable. Now, intention could be measured in two categories. One, I do have an intention to study, and the second is, which is a larger chunk, no intention to study in the class. So what happens is, I hope all of us understand, when you have this type of information, we need to assign some values or codes. I have assigned 0 to no intention and 1 to intention. So you can see here the two lines parallel to x-axis. These are y equal to 0 and y equal to 1. Now, having said this, what would be the type of the curve which you will have when I forecast? It would be a type of a S. This would be a type of a, ये ऊपर निकल गया. I think I have it on the slide itself.
मम्मा पास जाओ. ऐसे नहीं करते कोको.
Akash, would it not be possible to use the board? नहीं. Otherwise इस पे पढ़ने में मजा आ नहीं पाएगा. But issue ये नहीं है. Issue ये कि would the people who are there online would be able to view? They won't be. नहीं, इस पे लिख नहीं पा रहे हैं. So you can do it. हाँ हाँ सर हो नहीं पाए, वो मजा नहीं आएगा इस पे. हाँ नहीं, मेरे ख्याल से इससे इसके माइक इससे नहीं, इसके कैमरा से नहीं हो सकता है. हाँ क्योंकि नहीं, हाँ इसमें और उसमें पढ़ाने में भी वो मजा नहीं आ रहा. हाँ हाँ वो आप कंसंट्रेट कर रहे हैं मोर ऑन राइटिंग एज कम्पेयर टू स्पीकिंग. ओके एक डस्टर भी दे दीजिए. बस that's it. पर शुरू हो जाए. हाँ हाँ, टेक योर टाइम. आप शेयरिंग कर रहे हैं अभी? नहीं सर, मुझे नहीं जरूरत. आप एक काम करो, यू कैन शेयर दीज स्लाइड्स विद द पार्टिसिपेंट. नहीं अभी आप अभी कर दीजिए, कोई दिक्कत नहीं. राइट. हाँ, पेमेंट मार्केट मत करना. You can share the slides, data, everything with the participants. Let them have it. Now this is more of a classroom, which I'll enjoy. As we tend to grow old, our propensity to use the technology tends to lessen. So I think traditional teaching would be a better option. और वैसे भी क्या कहते हैं, face to face teaching and face to face delivery is always much better as compared to the virtual delivery. SPSS शेयरिंग की जरूरत पड़ेगी. सर देखिए, SPSS की जरूरत पड़ेगी जब सर SPSS कराएंगे. ठीक है बेटा. और उसी को शेयर कर. हाँ तो उसी को सर बिल्कुल बात है. It's not visible. So you want me to? I am writing with the biggest of the font. You want me a much bigger font? Okay. So just write few words. I think. Is it visible? Let me just. Like little bit more. Much bigger. I will keep it there.
Yes, sir. Thank you very much.
Right. So, what is the number of people who are there online?
Right now, 93. So just wait.
Please go ahead. So Vikas, ready to go?
Black dot.
No. अभी आ रहा है हाँ बस ब्लैक हो रहा है इस पे डबल टैप करना पड़ रहा है बार बार राइट इधर से मुझे बार बार इसको ऑफ करना फाइन बट ऑफ नहीं टच हाँ इट इज वर्किंग राइट नाउ अभी ये कंप्लीटली एक्टिव है कोई इशू नहीं अभी गॉट दैट Yes. Students. Yeah, विकास इसका मेन हाँ आ गया हाँ हम नहीं है
अच्छा
हाँ इसे पिन करके फाइन
Done?
अब देखो अब देखो
प्लीज आस्क द कस्टमर वेयर इज विजिबल लाइक
सौम्या को विजिबल है ना यस बस ठीक है
Okay. Thank you. So, again, starting off, once again, yeah. This side. This side, can you lick that? अच्छा, ठीक, नहीं लिख. Done. Anything else? Perfect. So now, the dependent variable, which is your categorical in nature, it is taking two values. I'm giving this value y equal to 1, and I am writing here y equal to 0. So when a variable takes only two possible values, what would be the probability distribution? KG? Binomial distribution, right? So this is basically your dependent variable. Your dependent variable is a binomial variate, right? So this is where we are going to look in at. In linear regression, what you said, your dependent variable y was a continuous variable which followed which distribution? Normal distribution, right? So when you had a normal distribution, for your dependent variable, you have linear regression. When you have binomial or polynomial distribution for your dependent variable, then you have the binary logic or multinomial logic. Binary logic is this case where you have only two possible values. Multinomial logic would be when you have more than two categories into which your variable can be divided. For example, if आप सब लोगों ने क्रेडिट कार्ड कभी ना कभी अप्लाई किया होगा, आपके पास क्रेडिट कार्ड होता है. So when you apply for a credit card, each one of you is assessed on the basis of your risk, right? So either you are completely safe, or you are at moderate risk, or you are at high risk. So when you have three categories, then it will be a trinomial or polynomial logistic regression, which we are looking at. In this case, we are looking at only the binary logistic regression. Now, having said this, I'll try to give you again a comparative scenario. This was your multiple regression equation which you had studied yesterday. There is one concept which is there, which you call the disturbance term, which followed normal distribution, right? This U actually made this total equation stochastic, right? There is no disturbance term which we have in the logistic regression. Voice echo कर रही है, voice echo कर रही है, इसको हटा दें.
It will be visible on this screen, also the online. Sorry? Sir, use this tab. It will be, whatever the content you are using, it will be visible to both the online and the offline parts.
हटा दो मुझे.
Yes,
नहीं, इनका कहना है सर बोर्ड के बजाय इस पे.
that's the use, right? Use this.
अच्छा, I write on this.
Yes, sir. It will implement this and also the online parts.
अच्छा भाई.
Hello, online participants. Is the voice? Are you audible to me? Yeah, please confirm it in the chat box. Participants, dear participants, is the voice clear?
Yes, yes.
Thank you, sir.
Okay, thank you. So, am I good to go now? Huh? मुझे लगता है मुझसे पहले लोग सो गए होंगे. So the basic difference between your linear regression and the logic is that we do not have the disturbance term out here. The reason why I'm trying to connect the logic with linear regression is that there are certain concepts which you are already aware of from the yesterday's class. So whatever are the deviations from the regression, that should also be very clear to you. Now, when I look at this, here this y cannot be directly studied. But what we do, the reason why y cannot be directly studied is because y follows binomial distribution. Y is not a continuous random variable wherein we can easily go ahead and map it. So what happens is there's another concept which we have studied. All of us who are from statistics, they are well aware. Those who are not, there's a concept of odd ratios, odds in favor and odds against. So what is odds in favor? Suppose I toss a dice, toss a coin, and the probability of getting a head is 25%. So what is odds in favor of getting a head? 25%. And what is odds against? 75%. So here what we always talk about is, in logistic regression, we try to define y as odds ratio, which is odds in favor which is same as, if suppose odds in favor is denoted by pi, so odds against will always be 1 minus pi because the total value of probability is 1. So in other words, my logic, I have to then remove it. I have to remove this screen. Achha. Okay, that's good. So what happens is, my regression, logistic regression equation changes to in other words, if I want the equation in pi upon, that is only the odds ratio, what would be the value? It will be exponential of the same value. So this equation is said to be the equation of logic. And if you look at the predict values, now what will happen? This is the value of x equal to y equal to 0 and y equal to 1. So either, if I go by the example, intention to study and intention not to study. So y equal to 0, sorry. So your observed values, where would your observed values be? Your observed values will be here, or your observed values will be on the line here. These will be the observed values. But when you forecast, what will happen to the forecast? There will be certain forecasted values here. Because of certain errors in forecast, आपके कुछ values यहाँ भी हो सकते हैं, और उसके बाद आपके values यहाँ भी होंगे. So you can see this is the forecasted graph which is going to come, and this is called the S curve of your logit. This is your S curve of the logit. A logit is supposed to be efficient if the maximum cluttering of the forecasted values lies here and here, with the least value maximum values should be either close to x-axis or should be equal to the line parallel to the x-axis, whereas the minimum should be in the space between 0 and 1. If this is the case, then you have a efficient logic model made. और इसीलिए one of the very important concept is the frequency or the predictive efficiency is the misclassification concept. The matrix of misclassification tells you the efficiency of the logic model. Now, for regression, what was the tool which you had used for to discuss the efficacy of the regression model? R square, right? Coefficient of determination. यही कहा था ना आपने? The value lies between 0 to 1. If the value is 0, it means zero predictability. If the value is 1, then all the points would be on the best fit line. R equal to 1 means what? The observed and the predicted values, they overlap on each other. That would be the value of R equal to 1. For all practical purposes, na 0 मिलेगी, na 1 मिलेगी, है ना? So when you don't have 0 or 1, what will you have? You will have a value between 0 and 1. And that is where the whole concept of efficiency comes into the picture. In logistic regression, instead of R squared, we have pseudo R squared. We have a concept called, this is called pseudo R squared. And pseudo R squared there are two major people who have worked on the R squared. One is Cox and Snell, and the other one is your Nagelkar. So these are the two R squares which are actually being studied. Now, there is another concept which you had already studied. इसको क्या कहते थे भाई आप? Adjusted R square. What was the basic difference between the adjusted R square and R square? Degrees of freedom. Other than degrees of freedom, what? You have divided R squared by certain degrees of freedom, that is the degrees of freedom of regression to the degrees of freedom of errors. यही किया था ना आपने? Other than this, why? My first question to you is, why adjusted R?
Because as we on you adding more variables to the target variable, So if the RC value tends to like high, like close to 1, so that's why it will be like the conclusion is inappropriate.
तो अच्छी चीज है. I keep on adding the independent variables. My R square keeps on increasing. My predictive efficiency of the model keeps on increasing.
So, but how will you decide that that variable is actually it is like viable or not? Like is like truly facing the model or not? Like suppose you are ready to like 4-5 is added or added so 99 so आपको पता कैसे कि stop.
अरे क्या दिक्कत है? टी स्टैटिस्टिक लगाओ, चेक करते जाओ कि क्या कहते हैं आपका वेरिएबल सिग्निफिकेंट है कि नहीं है.
आज तो हाई रहेगा not only for number of variables it is administered for number of observations.
आप आर स्क्वायर बढ़ाते जाइए, कोई दिक्कत नहीं. टिल द टाइम माय टी स्टैटिस्टिक टेल्स मी अ वेरिएबल इज सिग्निफिकेंट, आई कैन गो अहेड. और इनसिग्निफिकेंट भी है तो भी अगर मेरे को अगर लिटरेचर कह रहा है, if it is saying that you can add the value variable, I can add the variable. The concerns are that you have to not only adjust the variable for diminishing return, you have to also adjust for the number of observations which go. That's the first point of R adjusted R square. Second, वेरिएबल ऐड करते जाइए, किसी ने मना नहीं किया. सोशल साइंस वाले बहुत वेरिएबल ऐड करते हैं. इनके पास बहुत सारा वेरिएबल होता है. इनसे कहिए 4 वेरिएबल या 8 वेरिएबल ले आते हैं और एक बड़ा अच्छा जवाब देते हैं सोशल साइंस वाले. जब मैं तो मैनेजमेंट पढ़ाता हूँ इसलिए मुझे मालूम है कि सर स्टैंडर्ड थ्योरी है. अरे भाई स्टैंडर्ड कहाँ से आया? सर स्टैंडर्ड क्वेश्चन है यूज कर रहे हैं. स्टैंडर्ड क्या ब्रह्मा साहब ने बताया था आपको कि भाई ये यूज करना है? इफ यू कीप ऑन, एक एस्पेक्ट तो ये है यू हैव टू एडजस्ट. सेकंड, कीप ऑन एडिंग द वेरिएबल. एक बड़ा खूबसूरत कंसेप्ट है मल्टीकोलिनियरिटी का. योर मल्टीकोलिनियरिटी विल कम एन इफेक्ट. तो आपका जो मैं कह रहा टी स्टैटिस्टिक देख लीजिए सिग्निफिकेंट है कि नहीं है. सबसे पहला काम मल्टीकोलिनियरिटी क्या करता है, वो उसी टी स्टैटिस्टिक को जो है ना वो उड़ा देता है, वो इनसिग्निफिकेंट बना देता है. So we need to look at the number of variables you are going to look in at. That's why we have adjusted R square. Secondly, adjusted R square would always be either less than or equal to R square. Never ever it will happen. Mathematically भी नहीं होगा ना ऐसा कभी भी. Never ever it will happen yet that your adjusted R square increases R square. हाँ, बाकी आप लोग कोई नोबेल प्राइज के लिए हो स्टैटिस्टिक्स में तो बात दूसरी है, शुरू करवा देंगे that you can have an adjusted R square greater than R square. Similarly, the basic difference between Cox and Snell. Cox and Snell, at times when you have too many predictor variables are your X variables. If you have too many predictor variables, Cox and Snell tends to break this limit of 0 and 1. At times you'll find it crosses the threshold of 1. And that is what makes the usage of Cox and Snell slightly difficult. Nagelkar worked on this limitation of Cox and Snell pseudo R square. And ultimately we were able to achieve an upper bound of less than 1. Ye iska drawback. You will never be able to achieve 1. You will never be able to achieve 1 in pseudo R square of Nagelkar, whereas you might have greater than 1 in Cox and Snell pseudo R square. So Cox and Snell and Nagelkar at times both are used in tandem to study the logistic regression's predictive efficiency. Right? Any questions here? भाई पूछते जाओ, अदरवाइज whatever I am discussing वो आपके बूस्टर्स भी बाद में कैच नहीं कर पाएंगे. Now, the third concept, How did you test for the significance of your regression model in regression? How did you test for significance? गुडनेस ऑफ फिट कैसे टेस्ट किया था भाई? काई स्क्वायर, गुडनेस ऑफ फिट, अनोवा, अनोवा से काई स्क्वायर से, अनोवा से। गुडनेस ऑफ फिट ऑफ द मॉडल की बात कर रहा हूं मैं, गुडनेस ऑफ फिट ऑफ द डिस्ट्रीब्यूशन की बात नहीं कर रहा हूं। लाइन इज बेस्ट फिट और लाइन इज नॉट अ बेस्ट फिट कहां से निकाला था? आर स्क्वायर से निकाल लिया था, काई स्क्वायर। क्या बोल रहे हो? अभी राजीव सर है नहीं ना, अभी अभी कल पढ़ा के गए यार, ऐसा मत करो। We use ANOVA to test for the goodness of fit of your regression equation. Yeah, we use ANOVA to check whether your R square is significant or not. है ना? यही null and alternate है ना? The R square is insignificant, that R square is significant, or the model built is not a good fit to the model is a good fit, and you use ANOVA. In logistic regression, in logistic regression, we use Lemishow's goodness of fit test, and this is based on chi-square test. This is based on chi-square test. Now, when you did the chi-square test, what was the basic assumption which you used for goodness of fit? चलो अब आ जाते तुम्हारे goodness of fit में, जहां पे आप पढ़ के आए हो। And what was the assumption on expected frequency or observed frequency? Huh? Huh.
Like each individual frequency should be less than, not less than 5.
Cell frequencies or class frequencies should not be less than 5, right? Whether observed or unobserved, that is theoretical. You should not have less than 5. Agar less than 5 was, then what we used to do? We used to merge the cells or club the cells. That's what you did in the same basic assumption that your observed and expected frequencies should not be less than 5 is actually what is generally followed in this Hoshmer test also. So Hoshmer test also works on the same chi-square under the basic assumption that my observed and expected frequencies should not be less than 5. अच्छा, ये assumption लिया क्यों है less than 5 का? ये लिया क्यों है? Less than 5 नहीं होना चाहिए, 5 या 5 से बड़ा। क्या फर्क पड़ रहा है डिग्रीज ऑफ फ्रीडम? क्या फर्क पड़ता है डिग्रीज ऑफ फ्रीडम का? 4 हो जाएगी डिग्रीज ऑफ फ्रीडम। अरे भाई, काई स्क्वायर डिस्ट्रीब्यूशन ही नहीं बनता है आपका काई स्क्वायर डिस्ट्रीब्यूशन ही, आई थिंक काई स्क्वायर सैम्पलिंग डिस्ट्रीब्यूशन, ये तो मालूम है ना? काई स्क्वायर सैम्पलिंग डिस्ट्रीब्यूशन, और काई स्क्वायर डिस्ट्रीब्यूशन का यही ग्राफ है ना? This graph starts to take shape only for n greater than or equal to 5. Otherwise तो आपका एक कर्व ऐसे आ जाते हैं for different values of n. So इसीलिए हम लोग we always keep this into mind that our frequencies, self frequencies, both expected and observed, should be greater than 5. So Hoffman-Levenshaw's goodness of fit test we'll be using for our goodness of fit test. I think एक काम करते हैं, let's run something on data and then we'll try to connect the dots of the theory. Shall we do it? इसको कैसे बंद करना है क्या? कुछ नहीं. I hope the data has already been shared, right? Two 06 I think. नहीं नहीं भाई तो कुछ
माइक किसी को यूज कर लेंगे, इसे कनेक्टेड ऑलरेडी.
अच्छा एक इसमें वो है, अगर हम लोगों ने पहले लॉक
मीटिंग आईडी सर, मीटिंग आईडी पास.
एक काम करते हैं, एक डेटा सेट और लेके आते हैं 10 के प्लस हर ड्राइव.
Is it audible, guys? Audible?
हाँ, yeah.
So if you want to hide this, press Control and Shift. It will hide control.
वो SPSS data is where.
If you have this problem, you can drop. Otherwise, go to more and just click this hide loading.
Okay.
This is file system.
बल्कि हम बस उसको मैंने भी देता Can I have another data from this? Okay, I was thinking we'll start with factor and then go to logic.
See the preview of participant.
Okay. Vikas, is it possible to share one more data switch with the participant?
Yeah, just share with me. Yes, then the participant you are saying. Fine.
Bank loan. Guys, I'm sharing another set of data with you. It's a bank loan data. So we'll be working on this data set. So I have already opened up the data set. The data is being shared. 2 minutes.
Sir, please confirm that whether the final result is shared by the data.
It has been received. Data has been received? Data has been received. So
ऑफलाइन पार्टिसिपेंट्स के लिए टेलीग्राम पे डेटा आ गया है, ऑनलाइन के लिए
Can you start now? Guys, can I start? Good. So, if you look at the data set, there are 4 variables which are given to you. The first one is the perceived risk, which is associated with the respondent. Thus, and this is in 0 and 1. 0 means low risk, 1 means high risk. Whereas the other 3 variables is the age of the respondent, is the income of the respondent, and assuming that the respondents are happily married, it is the years into the marriage. So we are trying to build a forecasting model for risk on the basis of age, income, and years of marriage. So this is the prediction model of risk which we are trying to build up. As we already know, all the stats. Why we have put 22? I have taken a very large value in the as bid, so that in case the values are lower, anything is perfectly fine. उसका कोई वो scientific sanctity नहीं है. It is just that I have put some value. आपका actual value तो data view में है. ये रहा. जहाँ पे it is only of 2 digit. उसके बिट का ये होता है कि जितना ज्यादा लिखना है लिख लीजिए, आपके लिए आसानी रहती है. Since all of us are aware that all the statistical tools and techniques are within the analyze head, so click at analyze, and within analyze go to regression. Within regression you have both binary logistic as well as multinomial logistic. Binary logistic is when you have only 2 categories, as this case. Multinomial when you have more than 2 categories. So analyze, regression, and binary logistic. So this is the variable, this is the dialog box which opens up. My dependent variable is risk. My independent variables are the other 3. Now, we look at the predictability. Now, this predictability is what are the probabilities you try to associate. At times we say, I want to be unbiased. I want to be unbiased, so I want to give 50% probability to odds in favor, and 50% for odds against. Right? This is when we tend to be unbiased. But now what happens, suppose in this class itself, the total data set is highly tilted towards those who are at low risk. And I'm going to build up a regression model on this. What would happen? The model will be slightly biased towards the low risk people or not? Yes or no? Right? So, इस मॉडल को हम इसका how to remove the bias? To remove the bias, we generally tend to have equal probabilities attached for low risk or to have a high risk. At times there are people who say, "But I don't have any information per se whether I want to give equal probability or not." So we say, "भाई जितनी आपकी strength है उतनी probability ले लीजिए." So if low risk is 40% and high risk is 60%, automatically the probability would be 0.4 and 0.6. It is always advised to have a equally likely concept inbuilt, because that tries to remove the bias when the data is tilted towards one of the categories. It removes that bias when the data is tilted towards one of the categories. But having said that, ये कोई ब्रह्म वाक्य या राम वाक्य नहीं है. It varies from researcher's thought process to researcher's thought process. I will go with equal probabilities. Now for goodness of statistics, you have Hochman-Lehmann-Schau's test for goodness of fit. You have under options, you have Hochman-Lehmann-Schau's test for goodness of fit. Sorry? अभी बता रहा हूँ सारे steps. Here, first go to save. First go to analyze. Within analyze, go to regression. Within regression, go to binary logistic. The dialog box opens up. Dependent variable is your risk associated. So move the risk associated to the dependent variable. All the three independent variables move to the covariates. Done? Then click at save. In save, the first aspect is what is the probability of predictive probability you want to associate. या तो equally likely predictive कर लीजिए या depending upon the size of the data. Personally, I always use equal probability because if the data is leaned towards one of the category, then you are tending to be biased in terms of prediction. Right? It's your call whether you want to take the group memberships as the size or you want to take the predictive probabilities. Acha. For residuals, you want the unstandardized residuals or logic residuals? I want logic residuals. Continue. Under options, we go in for Hochman-Lehmann-Schau's goodness of fit. I continue and okay. Now the approach which we follow in logistic regression is first it builds the base model and then it tries to include the variables into the base. So first what you say, you can see here is the base model with 100% classification efficiency. You can see here there are 18 observations which are there, one missing values. you have two codes, 0 and 1 as low and risk, and in terms of this is 9 are high risk and 9 are low risk. Sorry, observed error. Okay, so this is what is there as the base. We don't have to read that base model. We have to read the values from ये देखिए बेस मॉडल में ना they have shown that these are the variables which are not there. These are the variables which are not there in the model. So now they are going to include these variables later on into in the model. This is your first table of model summary when the variables are included. Sorry? इसको बंद कर दे, हम यहीं से चले. अच्छा यहीं से चलते हैं. चलिए मॉडल समरी. So if you can see here, there are two R squares which are mentioned here. One is Cox and Snell and the other one is Nagelkar. The interpretation of R square, how did you interpret the R square coefficient of determination? You talked about the percentage of variations in the dependent variable which is explained by the model. This is what you said. You said percentage of variations which is explained. Here it is the likelihood. Here it is the likelihood. That is the chances. Here we do not have the percentage variance. Here we have the likelihood of. Right? So the interpretation goes like 86%. 86% is the likelihood that a respondent would be correctly classified in its category. Yeah, 64.5% are the chances that they will be classified in their respective category. Higher the value of pseudo R square, the better it is. Generally, in research papers, when we generally quote Nagelkar R square. Some of the authors, they quote both Cox and Snell and Nagelkar, and then give due importance to Nagelkar. My humble submission would be don't quote both, because if you quote both, you are yourself inviting a comment of the reviewer. Why have you quoted this and not this? Or why have you quoted both of them? It is always advised and it is always accepted, especially in behavioral sciences and social sciences, that Nagelkar's R squared is the quoted pseudo R squared. Now, then we talk about the efficiency. We talk about the efficiency of the model using Hausman-Lemminghaus test. What is the null and alternate hypothesis which we generally have? What is the null and alternate hypothesis which we generally have? Sorry? No, acha. Okay. Okay. So the null and alternate hypothesis here, we have made a base model and then tried to improve the base model. The reason of improving the base model is that as the log likelihood squared, inverse log likelihood squared decreases, the predictive efficiency increases. So the null hypothesis is that the whatever is the base model, the built model is close to the base model. That is, there is insignificant difference between the base model and the built model. While it is that there is significant difference between the built model and the proposed base model. In this case, you can see the degrees of freedom is n minus k minus 1. There were 3 independent variables. So you have 3 minus 1, that is 2. And the p-value is 0.797. So p-value of 0.797. नहीं लिख सकते ना कहीं? I cannot write anywhere. अच्छा change करना पड़ेगा. नहीं तो don't change. I hope we are aware of the p-value approach of testing of hypothesis. उसमें दिक्कत. We are aware of the p-value approach. If p is greater than or equal to alpha, we do not reject the null hypothesis, or we are unable to reject the null hypothesis. If p is less than alpha, we reject the null hypothesis. Is there any caveat to this thumb rule? Is there any caveat to this thumb rule, or we blindly apply this thumb rule? Huh? Yeah, what is the caveat? कौन से टेस्ट है जनाब, हम भी जानना चाहेंगे, बताइएगा. Is there any caveat to this, or we directly apply? अरे अच्छा, यहाँ पे कितने स्टैटिस्टिक्स वाले बैठे हैं, देखो तुम्हें. हाँ, देखे नहीं कितने लोग हैं भाई? How many of us are from statistics? भाई एक. अच्छा, कोई बताने ही नहीं चाहता है. भाई ध्यान रखिएगा, डोंट यूज दिस रूल ब्लाइंडली. There is a caveat to this thumb rule, and it is the biggest caveat. This can only be applied when the position of P and alpha is on the same tail. अगर पोजीशन ऑफ P और अल्फा दोनों उसी टेल पे है तभी ये थंब रूल लगता है, अदरवाइज ये थंब रूल लगता नहीं है. If alpha is on the left tail and P is on the right tail, ये थंब रूल नहीं लगेगा. Because P automatically lies in the acceptance zone. लगा भी मत देना भाई कभी. एक होता है गलती, एक होता है ब्लंडर, एक उसके ऊपर भी कुछ होता होगा. Right? So please, for heaven's sake, don't apply this rule blindly. P greater than equal to alpha and P less than alpha is the rule which is applied only when the position of P and alpha are on the same tails, otherwise not used, never used.
How will we know they are on
आपकी ऑल्टरनेट हाइपोथेसिस के 3 प्रकार हैं, या तो इट विल बी नॉट इक्वल टू टाइप, या फिर इट विल बी ग्रेटर देन टाइप, या फिर इट विल बी लेस देन टाइप। यही 3 तरीके हैं ना। If it is not equal to type, it means you have a two-tailed test. If it is a greater than type, then it's a right-tailed test. If it's a less than type, it's a left-tailed test. So the very moment you define your hypothesis, quantify your hypothesis, alternate hypothesis बात कर रहा हूँ, for all practical purposes, it is the alternate hypothesis which is made first. So the alternate hypothesis is derived from either your observation or literature or from somewhere else. So it is the alternate hypothesis which comes first. The very moment you quantify your alternate hypothesis, you automatically know where is alpha. And depending upon the test value, अगर positive है और अगर t test है, positive है तो right side पे जाएगा, negative है तो left side पे जाएगा. chi-square f है तो वो कभी उसमें positive negative होता ही नहीं, positive होता है. Right? So depending upon, अगर दोनों राइट साइड है तो अप्लाई कर लो, दोनों लेफ्ट साइड है तो अप्लाई कर दो, अदरवाइज मत करना प्लीज. डन. अगर अल्फा आपका राइट पे है और पी लेफ्ट पे है, तो पी किस जोन में लाई कर रहा है? एक्सेप्टेंस रीजन में ना. तो अप्लाई क्या करना है पे? वो तो ऑलरेडी एक्सेप्टेंस जोन में है, तो नल रिजेक्ट नहीं कर पा रहे भाई, तो मेहमान आ गया बैठा लो. Now you can see this is the predictive. Sorry. So what is the end result of Harshman-Lemming-Shaw? Yup. Chi-square test है ना? It's a chi-square test. So my P and alpha both will be on the same tail. क्या फर्क पड़ने का है? Your P is greater than alpha, right? Alpha is supposed to be 0.05 and P is 0.797. So it means even after introducing all the 3 independent variables, we have not been able to significantly change the base model. So this base model does not significantly changes from the base model, right? Although your predictive efficiency is 86% or 64.5%, depending upon whether you are taking Nagelkar or Cox and Snell. Look at the classification matrix. If you look at the classification matrix, the observed low risk and the predictive low risk are 8. And one low risk variable, one low risk respondent has been misclassified as high risk. One low risk respondent has been classified as high risk. Similarly, out of 9 high risk, 8 have been correctly classified and 1 is wrongly classified. So if you can see, out of 18, 16 have been correctly classified and 2 have been wrongly classified. Overall, 88.9% is the classification efficiency of the model. Now I come to the last table of yours. Now, how do I interpret the beta coefficients here? भाई इसके लिए तो आई रिक्वायर पेन.
So work करना पड़ेगा.
इसी को लगाएंगे.
वैसे इसमें
अच्छा ठीक है. Thank you.
स्क्रीन पे लिखना पड़ेगा, अलग लिखना पड़ेगा. अगर ब्लैंक चाहिए तो इसमें आराम से हो जाएगा.
हाँ एकदम ब्लैंक.
ब्लैंक लिखना. हाँ, you can just write here. उसे स्क्रीन शेयर चेंज करना पड़ेगा.
मुझे ये विजिबल रहेगा नहीं.
ये आपको विजिबल होगा.
ठीक है.
वो स्टॉप कर देगा इसको. देखिए आप, सॉरी, आप इसको मिनिमाइज कर दीजिए. कहाँ पे आपको से अपडेट.
So we are looking at the variables in the equation which are there. I am not sharing the screen. I think you already have the screen with you. So first of all, let's interpret the beta coefficients. How did you interpret the beta coefficients in regression? You directly interpreted. You said for 1 unit change in X, Y changes by beta units on an average. That's how you interpret it, right? That's how you interpret it. Here I cannot, because the values given out here are in log values. Here the values which are given to us are in log values, and secondly, these are all maximum likelihood estimates. So these are chances. So what we can do is, to interpret, I will take exponential of b minus 1 into 100. So for the first case, that is age, it is 0.206 minus 1 into 100. This is what? Approximately is 80%. It is approximately 80%. Then income 0, and years of marriage. This is 49.8% or 50%. Negative means what? Propensity to move towards 0. Negative means what? Likelihood is to move towards negative side. And negative side is what? 0 or not? So iska, if you interpret, if the age of the respondent increases, the chances of his becoming high risk decreases by 80%. the chances of the as the age of the respondent increases, the chances of the respondent becoming a high risk decreases by 80%. The other interpretation could be, as the age of the respondent increases, there are 80% chances that he would be a low risk person. So either chances towards 1 decreases or chances towards 0 increases. It is up to you how you interpret. Second, income has got no effect. Income has got no effect whether you increase the income or decrease the income. There is no effect on his likelihood to. Then the third is years of marriage. Years of marriage. Years of marriage has got a positive impact on likelihood to move to the high risk. The data is from the Western countries, so I don't want to go into the social aspect of the interpretation. I want to keep it to the mathematical aspect of the interpretation. And the mathematical aspect says, if as the years in marriage increase, there is approximately 50% chance, there's approximately 50% chance or 50% likelihood of his moving towards the high risk. So this is how you interpret. Now, if you look at the significance of each and every, variable which is there, in this case, we use the Waltz test, not the t-test. Waltz test is a normal distribution based test. So if you look at the test of significance of each and every variable, so my first hypothesis will be that age insignificantly influences the risk here you can see P is equal to 0.369, P is 0.05. Now insignificant influence is P is less than alpha. Sorry. So since P is greater than alpha, implies we do not reject the null hypothesis. You can see in all the three variables, your variable is insignificant. And I think it now, if you go back, it all integrates. Your model was insignificant, although you had a higher R squared. After model insignificant, so all your variables are also insignificant. None of the variables significantly influence your dependent variable, which is the risk perception of the respondent. Where is it gone? अच्छा, it directly share हो गया.
सर शेयर ये टैबलेट है सर, इसी नहीं है.
SPSS का है.
सर जब just click on share and this will do the share.
SPSS. में ब्रेक कर, ठीक है ब्रेक कर लो,
उसके बाद अगर के पहले फैक्टर पे आके उस फैक्टर पे लॉजिस्टिक this one output one I could say
so I'll quickly run through the outputs once again so as to understand the first. When they are writing block zero means this is a base model and we don't have to neither interpret nor quote. Then it comes to block one. Here they are writing the method is enter, that is the variables are being entered into the model, and this is the improved model over the base model. We interpret R squared. We have used the Hausman-Lawrence test, and then classification table, variables in the equation, and ultimately the misclassification. So this is how we actually go ahead and do it. I have shared the social sciences. Actually, I was under the impression that I'll first start out with factor analysis and then go back to logistic regression. I was unaware about the sequence. I have shared a social sciences data with you, right? So we'll first run the factor analysis after the break, and then come back on and run the logistic regression on the same. So that what you can see how your different aspects are taken care of in your factor analysis. Okay, so we'll take a quick break for okay, we'll take a quick break for 15-20 minutes and then come back for the factor analysis. After your half an hour, 45 minutes, now the things are cooling. So, आगे के लिए तुम्हारे बेहतर.
Want to engage with you. But sir, I'm going to just let me ask.
If they want to ask me question, I'll handle the question for you.
That is clear. So that all the party here, often one can hear the thing, and whatever the answer is deliver, it will be listened to all of them.
कुछ लोग ऐसे भी होता है ना कि जो कभी-कभी अनम्यूट करा लेते हैं.
मैं तुरंत हटा दूंगा अगर वो या तो एक काम करूंगा जो रेज हैंड करेगा उस पर आप करेंगे.
Zoom में मल्टीपल स्क्रीन नहीं शेयर होती है. Zoom जो होता है लाइक ये भी और ये भी.
मैंने देखा मैंने अलाउ नहीं करना है
पार्टिसिपेंट को नहीं अलाउ करने की एट द सेम टाइम वी वांट
लेट मी ट्राई प्रॉब्लम हो रहा है ट्राई कर लो
नहीं जाओ आ रहे क्या
शायद ही लिया है
जो कहा है वो सुनो. तुम भी सौम्या हाँ चार्ज पे लगाओ. और फटाफट जाके फटाफट कल वाली पीपीटी जो है वो हमारे रिसोर्स पर्सन है वो शेयर नहीं कर रहे हैं, अगर वो उन्होंने नहीं किया हमें, बट जूम का जो है पूरा रिकॉर्डिंग हुआ है, राइट लेक्चर, उसका
Dear online participants, the session will be started very soon. Please be patient. And now it's audible. Dear participants, now check the voice. Is it clear now? Okay, thank you, Madhu Gupta. Thank you, Swami. Thank you, all of you. Thank you for the confirmation. The resource person will come very soon. Please be patient. Please. Dear participants, someone please confirm that the audition. Yeah, please confirm once again. Yeah, any other participant? Please confirm. Please confirm the microphones, like the voice is audible or not. Anybody? Yeah. Yeah. Yeah, so the session will started very soon. The offline participants are there in the room, so there may be some sort of noise that will be cleared very soon. And yeah, let me. So if anybody have query, then he or she can raise their hand, and I will. That will be that can be heard here in the room by the participant as well as the speaker. Okay. So just raise the hand. Thank you. Thank you, Daniel. Thank you, Samuel. Yeah. Yes, Shashank. There's right now we are in lunch break, so the session will be started very soon. That's why the noise is coming.
Perfect. So where is this pad which I was writing on? Oh, oh. ये इससे जो व्हाइट सा पैड था वो यही हो गया ब्लैक. नहीं मुझे व्हाइट सा जो ऑन विच दिस इट. परफेक्ट. Okay, perfect. So we start off with factor analysis. Quickly, I'll take you through the theory of the factor analysis and then work on the factor analysis, because this is one tool which anybody who works in social sciences will have to use. Without factor analysis, आपका काम पूरा नहीं होने वाला है, as on date in social sciences. Right? The reason being, all of us study too much of psychological variables, that is psychographics, which you always study. Now, if we look at, I'll start off or connect the dots with the regression itself. Now, if you remember, what is the root cause of multicollinearity? What is the root cause of presence of multicollinearity? Again, मैं बार बार आपको regression में ले जा रहा हूँ, because regression is the technique around which everything revolves. What is the root cause of the multicollinearity? The independent or dependent? Independent variables, right? So when the independent variables are related with each other, what happens is आपकी जो स्टैंडर्ड एरर है वो इन्फ्लेट हो जाता है. स्टैंडर्ड एरर इन्फ्लेट हो जाता है, आपके जो सिग्निफिकेंट वेरिएबल्स हैं वो इनसिग्निफिकेंट. आपका कॉन्फिडेंस इंटरवल बढ़ गया, कॉन्फिडेंस इंटरवल बढ़ गया तो आपका वेरिएबल्स इनसिग्निफिकेंट हो गए. यही होता है ना. अब इन सोशल साइंसेज आप अपने वेरिएबल्स को कम कैसे करें? पहली दिक्कत तो ये है. सेकेंड प्रॉब्लम इज, फॉर एग्जाम्पल लॉयल्टी या आपका कमिटमेंट टू दिस क्लास. कैन आई डायरेक्टली आस्क, आर यू कमिटेड इन फॉर लर्निंग इन दिस क्लास? एवरीबडी ऑन अ 7-point scale 7 पे करेगा. स्ट्रांगली अग्रीड, यस. द रीजन इज, all of us tend to give socially desirable responses, है ना. We tend to give socially desirable. अगर हम कहें नहीं भाई तुम अच्छा नहीं पढ़ा रहे हो, हमें पढ़ने का बिल्कुल मन नहीं है, दिल में यही है, दिल में यही है, अच्छा नहीं पढ़ा रहे, हमें नहीं पढ़ना है. लेकिन जब पेन में, जब कागज में टिक करेंगे तो देन व्हाट वी डू, वी क्लिक एट 7 और 6. बहुत ईमानदार हुए तो 6 पे कर देगा, नहीं तो 7 पे कर देगा. It means these are certain variables which you cannot directly measure. हम सब यहाँ बैठे हुए हैं, हम लोग कहें कि we are very honest in our day to day behavior. अभी पूछ लूं मैं सबसे, 7-point scale पे ले लो, सब साफ है, सब साफ है और सब साफ है. So such variables can never be directly measured in a single statement. We tend to measure it through a number of statements. We try to measure through a number of statements. अब जब number of statements हमने measure किए तो क्या होगा? the variables are interconnected, intercorrelated, और जब वेरिएबल्स आपके इंटरकोरिलेटेड होंगे मल्टी क्वांटिटी तो होगी ही होगी. देयर इज नो वे आप मल्टी क्वांटिटी को रिमूव कर पाए. कितने वेरिएबल्स को ड्रॉप करोगे, कितने वेरिएबल्स को ड्रॉप करोगे, एक को, दो को, तीन को. आई होप दिस इज द वे यू रिमूव द मल्टी क्वांटिटी, राइट? ड्रॉपिंग द मोस्ट कोलिनियर वेरिएबल एट अ टाइम. उधर आइगन वैल्यू देखते जाओ, इधर बीआईएफ देखते जाओ, ड्रॉप करते जाओ. This is how we keep on bringing down the. And what do we say? We say we try to bring the multi-collinearity to insignificant level. We never say that we are able to remove multi-collinearity. Can you remove multi-collinearity by dropping the variables? हाँ या ना? Removal नहीं होता. So the other way, and especially the way in social sciences, where we are working on the psychology of the consumer, psychology of the customer, psychology of the employee, there the process or the concept which is generally used is factor analysis. And in factor analysis, what do? We put all similarly behaving variables, that is highly correlated variables, in a box, और उस बॉक्स को नाम देते हैं फैक्टर. All similarly behaving variables are put together in a box and that box is called factor. तो आपस में लड़ते रहो भाई, उसी बॉक्स के अंदर बैठ के आपस में लड़ते रहो, उसमें नाम दे दिया एक. So this is where factor analysis comes into the picture. Now, factor analysis majorly is based, I'm using the word majorly, I'm not saying is only, is majorly based on a concept called principal component analysis. क्या होता है ये प्रिंसिपल कंपोनेंट एनालिसिस? व्हाट इज दिस प्रिंसिपल कंपोनेंट एनालिसिस? ना डायमेंशन रिडक्शन तो फैक्टर एनालिसिस को ही कहते हैं, बट व्हाट इज पीसीए? व्हाट पीसीए डज टू in reducing the dimensions? What is the basic mechanics of principal component analysis? Yeah. हाँ सर, कैसे करता है ये मैं जानना चाहता हूँ. देखिए हाँ, एनीबडी एल्स? सॉरी, रेज करके. इट इज अ मेथड ऑफ एक्सट्रैक्शन जहां पर ईच अच्छा, अगर मैं इस क्लास में ग्रुप बनाना चाहूं तो क्या कैसे बनाऊंगा? मैं कोशिश करता हूं कि जो एक तरह के लोग हैं उन सबको एक साथ ले लो, जो बच जाएं फिर उनमें से फिर जो एक तरह के लोग हैं उनको ले लो, फिर जो बच गया उसमें जो एक तरह के लोग हैं उनको ले लो. बट दिस एक्सट्रैक्शन is done at 90 degrees. This extraction is done at 90 degree. We call it as orthogonal extraction. आपको मालूम है अगर दो लाइनें 90 डिग्री पे मिलती हैं तो उनके बीच में क्या रिलेशनशिप होता है? हाँ, परपेंडिकुलर तो होता है, बिल्कुल सही है. वो इंडिपेंडेंट हो जाती हैं, उनके बीच में कोरिलेशन 0 होता है. तो जो दो फैक्टर पीसीए से निकलेंगे उनमें कोई रिश्ता नहीं होगा, कोरिलेशन 0. कोरिलेशन जब 0 हो गया तो आपकी जो वो मल्टी क्वांटिटी कंडीशन नहीं थी रिग्रेशन की, that the independent variables should be independent among themselves, that condition is automatically fulfilled or not? That condition is automatically fulfilled. आप सबके पास डेटा है, लाइफस्टाइल का मैंने डेटा सेंड किया है. उसके साथ एक वर्ड डॉक्यूमेंट भी है। जरा उस वर्ड डॉक्यूमेंट को खोल लीजिए, आपको ज्यादा अच्छा समझ में आएगा। विकास मैं यहां से खोल सकता हूं ना? हाँ, कोई बात नहीं, तो अभी हम यही उनको विजिबल करा रहे हैं ना। तो हम now these are हाँ 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 हाँ, तो उनके पास अपना है ना। आई वांट देम टू लुक एट माय स्क्रीन, हैव अ लुक एट योर स्क्रीन। अब यार ये तुम देखो, है ना? आप देखते रहो, मैं इतने बोल रहा हूँ। यार दिस इज अ वेरी ब्यूटीफुल केस। हम लोग मैनेजमेंट में इस केस को बहुत पढ़ाते हैं। आपने कभी सोचा ये नेक्सा वाले, ये मारुति वाले क्या कर रहे हैं? कभी एरीना खोल रहे हैं, कभी नेक्सा खोल रहे हैं, कभी कुछ कर रहे हैं। आई डोंट नो हाउ मेनी ऑफ यू, एक सर को मालूम होगा, एक हमको मालूम है, या हमारे साथ के उम्र के लोगों को मालूम है। दे यूज टू बी अ कार कंपनी कॉल्ड क्राइसलर मोटर्स। वो मर्ज हुआ, डेमलर क्राइसलर बना, उसके बाद वो जाके मर्ज कर गया बेंज में। तो अल्टीमेटली यू हैव अ डेमलर क्राइसलर बेंज। इन अराउंड 1989-90 ये हमारे क्राइसलर मोटर्स को एक शौक चढ़ा। दे वांटेड टू लॉन्च अ स्पोर्ट्स कार इन competition with Porsche and other cars, sports sedan. और Chrysler Motor was famous for making the wagon cars. Wagon cars were similar to ये जो आप लोगों ने, बहुत लोगों ने अभी भी चला रहे हैं, वैगन आर चला रहे हैं ना। सबसे बेस्ट, मोस्ट टेक्नोलॉजिकली एडवांस एंड रोबोस्ट कार्स, वैगन कार्स, जिसकी डिजाइन जो कंसेप्चुलाइज की गई थी, दैट वाज कंसेप्चुलाइज बाय क्राइसलर मोटर इंजीनियर्स। तो अब आप ये सोच लीजिए कि बेचारा वैगन कार बनाने वाली कंपनी ने कहा मुझे तो स्पोर्ट्स सेडान लानी है, कंपीट करना है पोर्श से। करो भाई, मना किसने किया है? बिल्कुल यही सिनेरियो है हमारी मारुति 800 के साथ। मारुति इज परसीव टू बी अ स्मॉल कार मैन्युफैक्चरिंग कंपनी। वो बेचारे पहले ले आए मारुति 1000, फिर 2000 में लाए थे ग्रैंड विटारा। आई डोंट नो हाउ मेनी ऑफ यू आर अवेयर, ग्रैंड विटारा 2000 में आ गई थी, लॉन्च हुई, फेल हो गई थी। अपनी इमेज को चेंज करने के लिए स्लोली एंड स्टेडीली मारुति इज वर्किंग। पहले वो 1000 लाए, फिर स्टीम लाए, उसके बाद धीरे धीरे दे आर इंक्रीजिंग देयर पोर्टफोलियो। वो डायरेक्टली टॉप एंड मॉडल जो लग्जरी रेंज है बिल्कुल लेके नहीं आए, लेके आएंगे अभी। अपने आप को सेग्रीगेट करने के लिए दे हैव ब्रॉट इन नेक्सा एंड अरीना। तो ये जो केस स्टडी आपके सामने है, दिस केस स्टडी टॉक्स अबाउट, अगर मैं आपसे डायरेक्टली पूछूं गाड़ी खरीदोगे हमारी, आप कहीं से सोचेंगे क्यों खरीदेंगे, ठीक है ना? सो कैसे पता करें कि वेदर यू आर अ पोटेंशियल कस्टमर और नॉट? दे डिवाइस अ क्वेश्चनेयर। आई हैव टेकन a small portion of that questionnaire. It was a huge 79 question questionnaire. उसमें से हमने आपके लिए कुछ क्वेश्चंस लिए हैं, and their end question was, I can consider, I am using the word I can consider buying the car. That is, I am trying to check the intention of mine. All the remaining 21 statements are psychographic statements, psychological variables हैं आपके, और and they are a number of variables are similar to one another. अगर हम इन 21 के 21 पे फैक्टर वो रिग्रेशन चला देंगे, what will happen? There will be a huge multi-collinearity which will be there. To overcome that multi-collinearity, what we do is we try to divide these 21 statements. अच्छा, हम छोड़ भी नहीं सकते, हम कितनों को ड्रॉप करेंगे भाई? 1 2 3 4 5 6, ये डेटा आपके पास है। रिग्रेशन आप लोग पढ़ रहे हैं, इसी डेटा पे रिग्रेशन चला के देख लीजिएगा, बड़ा मजा आएगा। दिस इज वन एक्सरसाइज जो बड़ी इंटरेस्टिंग है। अगर महसूस है कोई इसके बाद, आकाश तुम पढ़ाओगे ना रिग्रेशन इसके बाद, है ना, इसी डेटा पे करा देना इन लोगों को, इसी डेटा पे, बिकॉज यू विल हैव हेटेरोजीनिटी आल्सो, यू विल हैव ऑटो कोरिलेशन आल्सो इन दिस डेटा। इन्हीं से कराओ इसी के ऊपर रिग्रेशन। So what happens is, अब similarly behaving variables है, हम ड्रॉप करेंगे, किस वेरिएबल को ड्रॉप करें किसको ना करें। अच्छा दूसरी बात, आप सब लोग से मैं सवाल पूछूंगा, कुछ कुछ आप जवाब देंगे, इसका मतलब कुछ तो कंट्रीब्यूशन होगा टू द एग्जिस्टिंग पूल ऑफ नॉलेज। अगर मैं आपको भगा देता हूं, सपोज 90% आप रिस्पॉन्ड नहीं करते, 10% तो करते हैं ना, so I am losing out on that 10% of the data. Factor analysis is supposed to be better to dropping of variables for removal of multi-quantity, because loss of independent data doesn't happen. Loss of correlated data कोई दिक्कत नहीं, independent जो आपका original data है that is actually preserved. So that's the advantage. But for factor analysis there are 3 basic assumptions. Sir, can I start writing now? मुझे क्या करना होगा, इसको मिनिमाइज करना होगा। विकास या तो तुम मेरे असिस्टेंट बन जाओ या मैं तुम्हारा। अच्छा ओके, तो कर दो ना क्लिक, इसी के ऊपर लिख। अच्छा ठीक। So there are 3 basic assumptions which are there for factor analysis. The first and foremost assumption is that variables are measured on the metric scale. That is, either they should be interval scale or ratio scale. Ordinal or nominal measured variables पे factor analysis नहीं चलता है। Second, variables are correlated. If the variables are uncorrelated, तो भाई हम डब्बा में बंद किनको करेंगे। So there has to be decent enough correlation amongst the variables. और जो तीसरा और सबसे इंपॉर्टेंट चीज है, sample size should be large. Under these 3 assumptions you can apply factor analysis. If assumption number 1 and 2 are not met, factor analysis is not applicable. So factor analysis can only be applicable if 1 and 2 assumptions are met. For third assumption, at times we tend to violate it. At times we tend to violate it. Now, how to test the correlation? We use Bartlett's test. Bartlett's test of sphericity is the test which we use for testing whether the variables are correlated or not. Whereas for sample size is large, the test which is used is called Kaiser-Meyer-Olkin test, KMO test. Kaiser-Meyer-Olkin sample adequacy test. That's the test name. But the thumb rule is that the sample size that's it, n should be equal to 4 to 5 times the number of variables. So in case the sample adequacy test fails, and still if your data is 3 to 4 times the number of variables, still you can go ahead. So in the example which I was showing, you had 21 variables. तो अगर आपके पास 90 से 110 ऑब्जर्वेशन हैं तो भी आपका काम चल जाएगा. मे बी माई KMO टेस्ट विल फेल, but still I'll be able to run the factor analysis. But if Wallet's test fails, I cannot apply the factor analysis. विकास जी इसको ऊपर कैसे करेंगे? तो हमारे उसको इरेज कर दें. That's it. Thank you. ठीक है. This is a chi-square test with p minus 1 by 2 degrees of freedom. Now, when you are looking at the 21 variable, what would be the correlation matrix like? What would be the correlation matrix like? It will be 21 cross 21. It will be a 21 cross 21 matrix or not? The leading diagonal will be 1, and the off diagonal element will be the correlation, right? The correlation coefficients. So determinant of that matrix is 0. Determinant of that matrix is not equal to 0. Determinant of the correlation matrix. This test should lead to the rejection of null hypothesis. If the null hypothesis is not rejected, काम बंद, thank you. There is no other way. But it will never happen. Practically it will never happen because your variables अगर uncorrelated हैं तो multiplicativity है ही नहीं उसमें. Go ahead, apply the regression. Factor analysis acts as a prequel to any forecasting technique. Point number 1. Point number 2. For all multivariate techniques, कोई भी नाम ले लो, कोई भी correspondence analysis, cluster analysis, conjoint analysis, just put in any name. One prerequisite is there that the independent variables need to be independent among themselves. क्या इंश्योर करेगा? कहां से इंश्योर करोगे? You can only ensure if you are working in behavioral sciences. Factor analysis through principal component analysis, you are able to ensure it. जी. लॉजिस्टिक रिग्रेशन में भी अगर क्या कहते हैं आपके इंडिपेंडेंट वेरिएबल्स डिपेंडेंट हैं एक दूसरे पे, तो व्हाट विल हैपन? आपका आर स्क्वायर भी गिरेगा और आपके जो वॉल्ट्स टेस्ट है वो भी इनसिग्निफिकेंट हो जाएगा. बिल्कुल फैक्टर एनालिसिस इज, क्या कहें, नमक और चीनी है आपके खाने में, जिसमें चाहे मिला लो, राइट? इट इज अ बेसिक इंग्रेडिएंट. दैट्स व्हाई आई ऑलवेज से दिस इज अ प्रीक्वल टू एनी टेक्निक. और इसी को ध्यान में रखते हुए आई वाज थिंकिंग दैट आई विल फर्स्ट स्टार्ट ऑफ विद फैक्टर and then maybe go in for logistic and anything, right? Now any given factor, so suppose my first factor is lambda 1 x1 plus lambda 2 x2 plus lambda 3 x3 and so on, where lambda i's are called your weights which you associate to a given variable in that given factor. उस फैक्टर में उस वेरिएबल का कितना कंट्रीब्यूशन है, these are called factor loadings also, factor weights or factor loadings. These are your factor weights and factor loadings, and they tell you how important is a variable in a given factor. Generally what you will find is all those factors which are similarly behaving will have higher impact, and those who are not similarly behaving will have lesser impact, right? So if I, sorry, oh yeah, पढ़ा वेरिएबल मैं रहा हूं और तुम्हारी तो अब क्या करूं? So extraction of factors, when we extract the factors, there are two methods of extraction. The first one is your principal component analysis method, where each factor is extracted at 90 degrees to each other. So when each factor is extracted, everything is touch me not. So when each factor is extracted at 90 degrees, so the first factor is called the principal factor, the most important factor. The second factor is slightly lesser important. Third factor is slightly lesser important, and so on. Now, in each factor, the amount of variability which will be preserved or captured will always be less than the previous factor. That's why वो principal factor कहलाता है. So the maximum variability will be preserved in the first factor, slightly less in the second, slightly less in the third, slightly less in the fourth, and so on. And so on. No points for guessing, but how many factors can be built? Suppose on a 21 variable, how many factors can be built? Huh? How many factors can be built? 4, 5. वो कोई यूरेका कंसेप्ट नहीं है 4, 5. वो तब हो सकता है जब तुम्हारी डायरेक्ट ब्रह्मा के साथ हॉटलाइन पे बात होती हो. The number of factors which can be extracted on a given data set depends is same as the number of variables on which you are running the factor analysis. In this case, there are 21 variables, so 21 factors will be extracted. I again repeat, 21 factors will be extracted. So 21 factors will be able to capture 100% of the variables. Now, since some lady here said factor analysis is dimension reduction, so the other important work of the factor analysis is it tries to reduce the number of variables on which you have to do the analysis. So in doing so, what happens? हमने number of variables भी reduce किए, multi quantity भी कम करी, खत्म करी, sorry. So using PCA, you are not only able to minimize the number of variables, but also remove multi-quantity. That's the basic task of factor analysis. So it reduces the number of variables. यहां पर आपका 5 आएगा कि 6 आएगा, ये आपका चॉइस होता है. The second one is your principal axis factoring. It is called principal axis factoring. Here, the factors are extracted at any angle other than 90 degrees. They are extracted at any angle. Any angle का मतलब क्या है? 90 के ऊपर का एंगल मत ले लेना. Any angle other than 90 degrees. So when it is extracted at any angle except 90 degree, उनके बीच में correlation होगा? अरे उनके बीच में correlation होगा कि नहीं होगा? So when you extract factors using PAF, that is principal axis factoring, there would be correlation between the factors which you have extracted. There would be correlation between the factors which you have extracted. So if you are using factor analysis as the feed for further research, humble advice, please use PCA instead of PAF. इसीलिए in behavioral science, if you read the research papers, in 99.99% of the cases, the factor analysis is performed using principal component analysis. Now, the second aspect is decision on the number of factors to be extracted. यहां पर हम 4 करें, 5 करें, 6 करें, how to go about doing it? There are there are two approaches of decision. First approach of decision is on मैं लिखता सीधा हूं, ये ऊपर नीचे हो जा रहा है. Till the time people are able to understand, चलेगा. Eigenvalue approach. So the first approach is eigenvalue. Now what is eigenvalue? चलो देखें कितने लोग को पता है. अरे हमारे मैथ्स वाले लोग बैठे होंगे, स्टैटिस्टिक्स वाले बैठे होंगे, बता दो भाई आइगन क्या है. गुरुजी को बताना पड़ रहा है यहाँ पे बैठ करके. रोज और कॉलम्स होते हैं किसी भी मैट्रिक्स के आइगन वैल्यूज. रहने दो यार, बाकियों के आगे उसको भी ऐसे रहने दो. कैरेक्टरिस्टिक इक्वेशन उसके रूट्स पढ़े हैं ना. रूट्स ऑफ द कैरेक्टरिस्टिक इक्वेशन इज कॉल्ड योर आइगन वैल्यूज. राइट. यहां पे आपकी इक्वेशन क्या है? 21 क्रॉस 21 की मैट्रिक्स बनेगी कि नहीं बनेगी? सो एक्स प्राइम ए एक्स मॉडुलस इक्वल टू, यही तो आपकी कैरेक्टरिस्टिक इक्वेशन बनेगी. रूट्स ऑफ दिस इक्वेशन would be the characteristic roots, and these are called eigenvalues. Please always remember the total of eigenvalues will be equal to the total number of variables. In this case there are 21 variables, so the total of eigenvalues will be 21. 21 ही आपस में डिवाइड होगा 21 लोगों में. Right. So this is what eigenvalue is. The thumb rule for eigenvalue approach is that the eigenvalue should be greater than 1. Have number of factors for which eigenvalue is greater than 1. अब यहां पर greater than 1 ब्रह्मा ने नहीं कहा आपसे, because you wanted that the dimensions or number of variables be reduced. So at least each factor should be able to completely represent one variable, right? Each factor should be able to represent at least one variable. इतना तो हो ना. So that is the thumb rule, that the eigenvalue should be greater than equal to 1. If we try to see how many factors, the number of factors to be extracted should be able to be as eigenvalue greater than 1. The second approach is more diagrammatic, and this approach is called scree plot approach. अभी स्क्रीन चलेगा ना ये? हाँ चल रहा. Scree plot is a plot of on this side you have number of factors, and here is your eigenvalue. So here you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the number of factors. So we draw a graph like this. The very moment you get an elbow, factor corresponding to the elbow is the number of factors should be extracted. So maybe my first elbow is here, so number of factors to be extracted corresponds to this. Why elbow? Can anybody tell me why elbow? In an elbow what happens is, देखिए यहाँ पर there is a steep decline, and after the elbow the decline is very slow. So major variability is captured here. इसके बाद आप जैसे जैसे आगे चलते जाओगे the magnitude of variability which will be captured would be very less. Would be very less. That's why the elbow is located. The biggest drawback or disadvantage of scree plot is, since it is indicative or diagrammatically identified, there may be number of factors which you can identify and at times will result in confusion. So scree plot is objective, eigenvalue is an objective method of factor determination, whereas scree plot is subjective. Majority of the researchers, they bank their decision on eigenvalue approach. Sorry. Another important aspect is, what is the basic difference between cluster analysis and factor analysis? Both are interdependent techniques. दोनों में अंतर क्या है? क्या नहीं है? अरे हमारे स्टैटिस्टिक्स वाले तो बता देंगे कुछ. हाँ हाँ हाँ. भाई आप क्लस्टर बनाते हैं तो क्या करते हैं? सिमिलरली बिहेविंग लोगों का एक गुच्छा बना देते हैं, ग्रुप बना देते हैं, कहते हैं दिस इज अ क्लस्टर, राइट? फैक्टर में भी क्या कर रहे हो आप? सिमिलरली बिहेविंग वेरिएबल्स का एक गुच्छा बना रहे हो ना. बट देयर इज अ ह्यूज डिफरेंस. पहला, in factor analysis the variables are grouped, in cluster analysis the respondents are grouped. That's the first. Second difference, in factor analysis the variables are grouped on the basis of variability. In factor analysis the variables are grouped on the basis of variability. In cluster analysis the respondents are grouped on the basis of their distance. They are grouped on the basis of their distance. आप उसको यूक्लिडियन डिस्टेंस बोल देते हैं, right? So please understand, both are interdependence techniques. एक में वेरिएबल क्लब होते हैं, एक में लोग क्लब होते हैं, एक में वेरिएबिलिटी के बेसिस पे करते हैं, एक में डिस्टेंस के बेसिस पे करते हैं. Having said this, you can use cluster analysis to club the variables, but the end results will not be good. ऐसा मैं नहीं कह रहा हूं कि आप नहीं कर सकते हैं, कर सकते हैं, but the end results will not meet your objective. The third aspect, third aspect group के बताते हैं. पहले I'll run the SPSS on this so that you are able to follow up till here. Then I'll teach you the remaining portion. सर कैसे जाएं? मुझे इससे परमिशन लेनी पड़ रही है सर. Okay. So here you have (400) respondents. You have the responses from 400 observations. And if you look at the variable view, the first variable is the intention to buy. From variable 2 onwards are all lifestyle statements. From variable 2 onwards are all lifestyle statements. So my objective is to reduce them into meaningful डायमेंशंस। तो चलिए शुरू हो जाइए। गो टू एनालाइज, डायमेंशन रिडक्शन, dimension reduction factor, except the first variable, I'm taking all 21 variables. Except the first one, I'm taking all the remaining 21 variables. I click at descriptives. I'm clicking at correlation coefficients. I'm clicking at, in the initial solution, I'm clicking at correlation coefficients. This is the data set on factor. Okay. Have they opened the data set? Can I proceed? All those who are unable to listen, again I'm saying, go to analyze, within analyze, go to dimension reduction. Within dimension reduction, you can have factor analysis. Take all the variables other than the first one. Take all the variables other than the first one. Remaining 21 variables are taken. Click at descriptives. Click at descriptives. Within descriptives, I am clicking at correlation coefficients. And since my objective was to check the assumptions also, you can see here towards the end there is KMO and Barlett's test. Continue, okay. So continue. Then I go to extraction. Now in the extraction, you can see you have principal component, you have principal axis. Other than that, you also have ordinary least squares, generalized least squares, and other methods of extraction also. Since our objective is to have independent factors to each other, so I am going to extract the factors orthogonally to one another. I am clicking at, so I am continuing with principal component analysis. You can see there is one scree plot also. Click at scree plot. Click at scree plot. Under extraction, you can see they have said based on eigenvalue. And by default, it is saying eigenvalues greater than 1. Again, you can change. If you want, you can have eigenvalue greater than 0.8. You can have eigenvalue greater than 0.6, whatever value you want. But the rationale of having one or more than one is at least a factor should be able to 100% explain a given variable. That's what the logic is, and that's why this eigenvalue greater than 1 is put in there. Continue. And I'm not going to go any further. I'll click OK. Yeah. अच्छा फिर से कर देते हैं. हाँ बाकी लोग ओके कर दीजिए, हम उधर ओके कर दें. Open the data set, please. Having opened the data set, go to analyze, dimension reduction, dimension reduction. In dimension reduction, go to factor. Shift all the variables other than the first one on the right hand side. Under the variables, click at descriptives. In the descriptives, initial solution is already highlighted. Click at correlation matrix coefficients. Also click at KMO and Barrett's test. Also click at KMO and Barrett's test. Continue. Click at extraction. In extraction, you have, if you look at the variables at the top, in the drop down, you have PCA, you have PAF, and you have other methods also like ordinary least squares and generalized least squares. Since our objective is to have, since our objective is to have independent factors, so I am going ahead with my PCA. Click at scree plot, click at eigenvalues greater than 1, continue, and OK. So this is your correlation matrix. The first is your correlation matrix. So you can see the correlation between good physical condition and dress for fashion is 91.91. The correlation between good physical condition and have stylish clothes is 0.619. Look different and good physical condition is 0.396. And so on, you keep on looking that there would be high correlation between the variables. What factor analysis does is all those variables which have very high correlation with each other, they are put together in one factor. All those, so the correlation matrix in itself gives you an indication, as to which all variables will be clubbed together. From correlation matrix, you get an idea as to which all variables will be clubbed together. Now this is your KMO and Barrett's test. You can see here so you can see my p value is 0.000. What was the null hypothesis? That the variables are insignificantly correlated, and the alternate is the variables are significantly correlated. We follow a chi-square test with p minus 1 by 2 degrees of freedom. So this is 21 into 20 by 2, that is 210 degrees of freedom. Alpha is 0.05, p is less than alpha. So it means we are rejecting the null in favor of alternate. It means, yes sir, yes. So the variables are significantly correlated. So my assumption is fulfilled. Your KMO value should be greater than 0.5. In this case, my KMO value is 0.75. Kaiser-Meyer-Olkin sample adequacy test value is greater than 0.5. It is 0.75. So it means my assumptions are fulfilled. My assumptions are fulfilled. I can go ahead and run the factor analysis. In case my Barrett's test failed, I cannot run the factor analysis. Plain and simple. Now, as we move down, this is the second table. In the first column, you can see there are 21 factors which have been extracted using the PCA. In the first column, you can see that there are 21 factors which have been extracted. In the second column, you have the eigenvalues. In the second, you have the eigenvalues. If you want to add it up, you can go ahead and add up. The sum total of these eigenvalues will come out to be 21. The sum total of these eigenvalues will come out to be 21. ना कम आएगा ना ज्यादा आएगा डेसिमल से भी. It will come out to be 21. The third is percentage of variations explained by that factor. आपने माना कि हमारा टोटल डेटा में 100% वेरिएबिलिटी है, तो पहले फैक्टर ने कितने परसेंट वेरिएबिलिटी डेटा की कैप्चर करी है? इट इज 4.728 divided by 21 into 100. 4.728 divided by 21 into 100, and that will come out to be 22.5. 4.728 divided by 21 into 100, it will come out to be 22.513. As you move down, आप देखिए हर फैक्टर अपने पहले वाले फैक्टर से कम वेरिएबिलिटी कैप्चर करेगा, and that is why it is called principal component. पहला वाला principal, second secondary component, third tertiary, and so on. Each factor will capture slightly lesser variability as compared to the previous factor, right? अब आप देखिए, up till 6 factors the eigenvalues are greater than 1. Up till 6 factors the eigenvalues are greater than 1. सातवें फैक्टर से वो 1 से कम हो गई है. As per your command, उसने आगे की फैक्टरिंग बंद कर दी. Since you have commanded that the number of factors should be greater than 1, eigenvalues greater than 1, उसने बंद कर दिया. So 6 factors together are able to preserve how much variability? 80% of the variability of the data. 79.497% of the variability. 6 factors, 6 factor 80% of the variability of the data preserve कर रहा है. Only 20% of the data is lost. Only 20% of the data is lost. Now what you have been able to achieve? आपको 6 uncorrelated factors मिल गए which are able to preserve 80% of your variability. So you have been able to remove correlation, you have been able to maximize variability preservation, and also minimize the number of variables. Now the question arises, कि sir, does every variable lose out 20%? The question arises, does every variable lose out on 20%? The answer is no. The answer is no. Some variables will lose out more, some variables will lose out less. Example के तौर पे, suppose in a class, if a faculty asks a question, क्या होता है? What is the scenario in a class when a faculty asks a question? सवाल पूछते हैं तो क्या होता है? पहले 2 मिनट तो सन्नाटा होता है ना? वो तो मान लिया. उसके बाद हाँ जी, बारी बारी से जवाब देते हैं. ये सोच के देते हैं, अरे इसने ऐसा बेवकूफी वाला सवाल का जवाब दिया, मैं भी दे सकता हूँ, सर के आगे कुछ नंबर बन जाएंगे. और क्या होता है? पहला वाला जवाब देता है, जो दूसरा खड़ा होता है, जो पहला बोला होता है उसका 10-15% तो वही रिपीट कर देता है, और बाकी का 85% कुछ नया अपना देता है. जो दूसरा वाला बेचारा खड़ा होता है, उसके बाद तीसरा वाला, वो पहले दो से थोड़ा थोड़ा लेकर के बचा हुआ अपना उसमें छौका लगा देता है। एज वी मूव, जब 10वां 11वें नंबर का नंबर आता है तो मालूम चलता है कि वो इतना इंटेलिजेंट होता है, वो सभी का थोड़ा थोड़ा कहीं से रोड़ा उठा करके वो अपना पिटारा जोड़ देता है, अपना कंट्रीब्यूशन कुछ नहीं होता है। इसी तरीके से इन फैक्टर एनालिसिस, those who are high contributors, they are able, there the preserving the variability is high. वो जिन्होंने सबसे जोड़ करके अपना कुछ भी योगदान ना देते हुए जवाब दे दिया, वहां पर preservation of variability is low. So higher the correlation, lower would be the preservation. And for that, please go to the table just above it. There's a table called communalities. There is a table called communalities. You can see before extraction, everybody had 100% variability. Before extraction, everybody had 100% variability. Post extraction, good physical condition, you are able to preserve 83% of the variability. That is 17% is lost. In dress for fashion, again you are able to preserve somewhere around 83% of the variability. Again 17% is lost. In the third case, only 70% is preserved, 30% is lost. In the fourth case, 56% is lost. Right? अच्छा, अब दूसरी इंपॉर्टेंट बात, जिस वेरिएबल की वेरिएबिलिटी ज्यादा प्रिजर्व होगी, उस फैक्टर में ही और शी विल बी प्लेइंग अ मोर डोमिनेंट रोल. राइट? सिमिलर, घर में अगर आप ज्यादा कमा के लाते हैं तो आपकी ज्यादा इज्जत हो जाती है. तो द वेरिएबल which has got a higher preserved variability would be playing a more dominant role in that factor. Please always remember. तो यहां से भी एक आइडिया लग जाता है हमको कि which are the variables which are going to be more dominating in a given factor and which are the variables which will be less dominating. अब आप देख लीजिए, बेचारा जब 44% वेरिएबिलिटी प्रिजर्व कर रहा है तो इसकी इंपॉर्टेंस इन द गिवन फैक्टर विल बी लो. And you can see there are certain factors like skeptical predictions are wrong. बिल्कुल नीचे चले जाइए, 93.4%. Only 6% is the variability which is lost. I can do anything. Again, you have a very high variability preservation of 94%. Only 6% is lost. So these are the variables which are majorly being preserved. लगभग 100% उनको preserve कर लिया गया है. So the loss is not always uniform. The loss differs from variable to variable. And higher you are able to preserve the variability, higher is the importance of that variable. Now this is your scree plot. This is your scree plot. You can see, हमें एल्बो देखना है ना. पहला एल्बो तो आपका देखिए 3 पे ही बन रहा है ना, लेकिन 3 के बाद फिर देयर इज अ ड्रास्टिक डिक्लाइन. नेक्स्ट एल्बो आपका 7 पे बन रहा है. नेक्स्ट एल्बो आपका 7 पे बन रहा है. उसके बाद 10th पे भी एक एल्बो बन रहा है. अब यहां पर झगड़ा हो जाएगा भाई. कुछ लोग कहेंगे हम तो भाई 3 ही फैक्टर बनाएंगे. अदर्स विल से दैट वी विल मेक 7, others will say 10. This is what I meant when I said it is subjective, open to interpretation, open to debate. You will not be able to defend your decision. So it's always advised to use the objective method of deciding the number of factors to be extracted. अच्छा, आप में से हॉस्टल कितने लोग रहे हैं? अच्छा, चलिए हॉस्टल छोड़िए, कितने लोग ट्रैवल करते हैं? सब लोग ट्रैवल करते हैं, वेरी गुड। अच्छा, द वे यू ट्रैवल, there is a huge difference in the way we pack. When I'm saying we, that is the males pack and the way females pack. अभी मैं कल आया हूं दिल्ली से, मेरी 4:30 बजे की फ्लाइट थी, मैं 2:15 बजे घर पहुंचा था। मैंने आधे घंटे में पैकिंग भी कर लिया, लंच भी कर लिया, उबर भी बुक कर ली, और मैं 3:20 पे मैं एयरपोर्ट की लॉन्ज में कॉफी भी पी रहा था। हम लोग कैसे पैकिंग करते हैं? वार्डरोब से ऐसे कपड़े खींचे, ऐसे पैक किए, अटैची में डाला, जिप, चल हो गया। लैपटॉप में जितना भी कूड़ा भरा है लैपटॉप बैग में, वो एज इट इज जाएगा, अगले दिन वैसे ही आ जाना है। ऐसे ही करते हैं ना हम मेल्स। अच्छा, विद ऑल ड्यू रिस्पेक्ट, फीमेल्स कैसे पैक करती हैं? वो पहले ड्रेसेस निकाल के बड़े कायदे से बेड साइड पे रखती हैं अपने, है ना? हाँ, तसल्ली से पैक करती हैं, फिर उससे मैचिंग बाकी चीजें निकाली जाती हैं। ऑन टॉप ऑफ इट, on top of it, when they pack it in the suitcase, अच्छा ये ड्रेस तो मुझे परसों पहननी है, सबसे नीचे रखो, ये कल जाते ही पहननी है, इसको सबसे ऊपर रखो। हाँ, ऐसे ही करते हैं ना आप लोग भी? आई डोंट थिंक माई ऑब्जर्वेशंस आर फेलिंग मी। इसी तरीके से लोग पैक करते हैं। आउटलायर्स के एनालिसिस स्टैटिस्टिक्स पढ़ाता नहीं है, ठीक है ना? सबसे पहले तुम्हारे गुरुजी ने यही कहा होगा, आउटलायर रिमूवल करो, उसके बाद पढ़ने आना। तो हम आउटलायर्स के एनालिसिस करते ही नहीं है। तो इसीलिए अब आप अपने सामने टेबल देखिए, यू कैन सी दैट देर आर 6 फैक्टर्स, एंड अक्रॉस ईच फैक्टर हर वेरिएबल का कंट्रीब्यूशन है। इन द फर्स्ट फैक्टर इफ यू सी, हाई फैक्टर लोडिंग्स कहां कहां पे हैं? नॉट हेविली इन डेट 0.892, लाइक टू पे कैश 0.90, spent cash 0.933, use credit cards 0.935, seldom use coupons 0.87, and interest rates are low 0.76. इसके अलावा बाकी सारे के सारे फैक्टर लोडिंग बहुत छोटी है ना। जनरली वी ट्राई टू लुक एट द फैक्टर लोडिंग्स विच आर ग्रेटर देन 0.5 या 0.45। 0.45, 0.5 के ऊपर ही हम लोग फैक्टर लोडिंग्स देखते हैं। सेकेंड फैक्टर में आ जाइए। अच्छा, इस फैक्टर में देखिए, अगर आप देखें सब सारे के सारे वेरिएबल्स, ऑल द वेरिएबल्स रिलेट टू द फाइनेंशियल या एक्सपेंडिचर बिहेवियर ना, फाइनेंशियल इन्वेस्टमेंट, फाइनेंशियल एक्सपेंसेस के बेसिस के ऊपर ऑल दीज वेरिएबल्स आर देयर। बट इफ यू लुक एट द सेकेंड, इसमें देखिए आपको नॉट गुड फिजिकल कंडीशन, तो गुड फिजिकल कंडीशन, ड्रेस फॉर फैशन, हैव स्टाइलिश क्लोथ, लुक डिफरेंटली, 0.45 से ये बड़े हैं। इसके बाद नीचे आइए, लाइक टू ट्रैवल द वर्ल्ड, डू समथिंग डिफरेंट, देन स्केप्टिकल प्रेडिक्शंस आर रॉन्ग, आई कैन डू एनीथिंग, इनकम हायर इन फ्यूचर। अब भाई यहां पर तो खिचड़ी बनी हुई है, ऊपर वाला तो कुछ ड्रेस सेंस की बात कर रहा है, नीचे वाला कुछ दूसरी बातें कर रहा है, तो यहां पे खिचड़ी बनी है। इसी तरीके से आप थर्ड, फोर्थ, फिफ्थ, सिक्स देखिए, each and every factor is not very clean, each and every factor is not very clean। तो हमने एक्सट्रैक्शन तो कर लिया, लेकिन हमारा एक्सट्रैक्शंस आर नॉट वेरी क्लीन। So what we do is, we then rotate the factors. We then rotate the factors. After extracting the factors, we rotate the factors so that the variability is properly redistributed. We rotate the factors so that the variability is redistributed. ये क्या हुआ? So this helps in clean profiling of the factors. भाई प्रोफाइलिंग करना, नामकरण संस्कार भी तो करना है ना भाई उन फैक्टर्स का. अगर खिचड़ी सरकार रहेगी तो नाम कैसे देंगे? So we need to redistribute the variability for clean profiling. Now factor rotation के there are a number of methods. There are a number of methods of factor rotation. The most used after is Varimax method. Varimax is variance maximizing method. Since our objective is to capture as much variability as possible, so we apply Varimax method of extraction. इसके अलावा there are here the rotation is at 90 degrees. Again rotation भी orthogonal है. In Varimax the rotation is orthogonal. The rotation is orthogonal. Other than this, there is Quantimax, Promax, and direct oblimin. These are the rotations at different angles, but they do not maximize variability. They do not maximize variability. Promax, अभी repeat ये आपको दिख ही जाएंगे. Other than this, there are Quantimax, Promax, Equamax, and direct oblimin. These are the methods, other methods of rotation, but they do not guarantee variance maximization. Right? So, having rotated the factors, you will be able to cleanly profile the factors and generate the factor scores. तो अब बचा हुआ काम भी कर लेते हैं. I go to analyze, I go to dimension reduction, I go to factor. तो मुझे भी नहीं दिखेगा भाई, इसको रिमूव कर देना. हाँ गुड. I go to rotation. ये देखिए whatever names I was saying, Quantimax, Varimax, Equamax, Promax, direct oblimin, everything is there. So I click at Varimax. I continue. Then I go for factor scores. Save the variables as regression. Continue. Options. Sort by size कर देते हैं. So that all rotation के बाद स्कोर सेव एज वेरिएबल्स कर दीजिए, एंड देन ऑप्शंस सॉर्ट बाय साइज, दैट इज इंपॉर्टेंट फैक्टर्स विल कम अप. I again repeat, go to rotation. In rotation, click at Verimax. Then go to score. Continue कर दीजिएगा. Go to score. Say, then go to score. Save as variables the regression scores. Then the last is options. Options में sort by size. अगर ये नहीं भी करेंगे तो कुछ आफत नहीं आने वाली है, बट सॉर्ट बाय साइज एक साथ क्लब हो जाती हैं. एंड ओके, now look at your eigenvalues table. Look at your eigenvalues table. It has redistributed the 80% of the preserved variability. It has redistributed. देखिए पहले the first factor was preserving 22%, अभी भी वो 22% ही लगभग variability preserve कर रहा है क्योंकि वो बहुत clean था. Second factor was preserving around 17%. Now it has been brought down to 13.3%. So it has lost some weight, lost some variability, which has been gained by the third factor. इसका 11.50 था, it has become 12.89. Fourth factor 11.33 से 11.18 हो गया. 9.56 की जगह 11.22 हो गया, and 7.69 जगह 7.79. The total variability remains same. Total variability जो सामान घर से फेंक दिया है उसको रीअरेंज नहीं करेंगे, जो घर के अंदर सामान है उसी को रीअरेंज करिएगा. So the total variability has been preserved at 79.497, but the same preserved variability is rotated or redistributed. अब आप लोग देखिए जरा अपने रोटेटेड कंपोनेंट मैट्रिक्स को. You can see the first factor has use credit cards, spent for today, like to pay cash, not heavily in debt, seldom use coupons, interest rates are low. इसके अलावा none of the variables in this given factor are dominant, and none of these variables are dominant in any other factor. किसी और फैक्टर में इनके पास कोई दमखम नहीं है. इन्होंने अपना सारा का सारा variability फैक्टर 1 में प्रिजर्व कर लिया है. Look at second factor. You have good physical condition, dress for fashion, have stylish clothes, look different. No other variable is significant in the second factor, and these four are insignificant across all other factors. These four are insignificant across all other factors. Then next, you have I can do anything, skeptical predictions are wrong, income higher in future. These are the three variables which are dominant in factor 3 and insignificant across all other factors. Similarly, in 4, considered to be a leader, self-confidence, other ask for help. These 3 variables are dominating the factor 4 and they are insignificant across all other factors. उसके बाद next is do something different. I like to travel the world, try new products. These again are the only variables which are dominant, and last factor has children are most important, spend the evening at home. So these are, so now you can see all the variables have been cleanly profiled. इनका नामकरण संस्कार कर दीजिए. Give certain names to these factors. The first one could be your expenditure behavior. Second could be your appearance. Third could be what? I can do anything. Skeptical, optimism. Right? By optimist है बड़ा. Then considered to be a leader, self-confident, others ask for help. Leadership quality कर लीजिए, leader. Then you have adventurous. Adventurous, I like to travel the world, try new products. Or maybe innovative, you can use the word. इन तीनों का एक नाम देना है ना. And last could be the family man, है ना. Family person, family man, whatever. वो serial वाला family man नहीं, हाँ यहाँ वाला. So instead of 21 variables, now you have only 6 variables. Instead of 21 variables, now you have 6 variables. अब वो variables हैं कहाँ? अपने जब डेटा शीट पे चले जाइए. ये रहे आपके 6 के 6 फैक्टर्स. These are your 6 factors which you have made. अब जो 21 variables है आपके वो बेकार हो गए, फेंक दीजिए उनको. You don't require them. These are the variables or these are the data which you will have to analyze. The factor score makes them continuous. Factor scores will make them normal. So जो आपका interval scaled variable था, which was non-normal, you have converted the non-normal variable into a normal variable, made it more continuous, and you have reduced the variables and removed multicollinearity. एक छोटी रिक्वेस्ट है आकाश जी, इसी डेटा के ऊपर कल इनसे रिग्रेशन रन करा दीजिए, है ना. एक बार बिना इसको क्लब किए और एक बार आफ्टर क्लबिंग इसी पे कराइएगा, so that they are able to understand the impact of multicollinearity with factor and without factor. Any questions here? हाँ हाँ हाँ. हाँ भाई, फ्रॉम द ऑडियंस एनी क्वेश्चंस? बिल्कुल चला सकते. Null should be rejected. Rejected. Yes. नहीं नहीं नहीं, देखिए पी वैल्यू चेक करिए ना, पी वैल्यू और सिग्नल. हाँ,
right now allow you to ask back to the person. So unmute yourself and ask the question. So let's just give me one second. Yeah. I just unmute. I just give you permission. Just unmute yourself and ask the question. Please unmute through one by one. Yeah. Yes, I'm doing that. So I have just allowed them to unmute themselves. They can unmute themselves and ask questions, and this will be all. And then they can try. Yeah. So, participants.
yes. अच्छा, वो statistics for management.
Able to hear me?
Authors
I have
Levin,
allowed
Ruben,
online
Siddiqui and myself.
to unmute themselves and ask question or interact with the resource person. The voice of yours
But for
will be
this
audible
topic,
to offline
जो आज
participant as
पढ़ाया
well
है,
as the resource person. So
उसके लिए it
just
is
unmute yourself and ask
multivariate
question.
data analysis.
If you have
Multivariate data analysis by Hare, H-A-I-R, Hare, Anderson, ब्लैक, एक ऑथर और भी है, मुझे याद नहीं है, पियर्सन पब्लिकेशन की बुक है, मल्टीवेरिएट डेटा एनालिसिस बाय हेयर, एंडरसन एंड ब्लैक, 4 ऑथर्स की है, एंड इट्स अ वेरी ब्यूटीफुल बुक. मल्टीवेरिएट डेटा एनालिसिस बाय हेयर, एंडरसन, ब्लैक और चौथा कोई और भी है, पियर्सन वालों का पब्लिकेशन है. इन केस आप लोग थीसिस लिख रहे हो तो यू कैन, ये इतनी अच्छी बुक है कि यू कैन कोट इट इन योर थीसिस आल्सो एज साइटेशन. हाँ, स्टैटिस्टिक्स फॉर मैनेजमेंट, लेविन, Levin, लेविन, रूबिन, RUBIN, सिद्दीकी सर, सिद्दीकी एंड रस्तोगी. हाँ जी सर. भाई, in case the online participants have any questions, please unmute and ask questions one by one. हाँ, from my side it is ended. Online participants, any questions, please? Otherwise, we are closing the session.
गुड इवनिंग सर, ये जो आपने सॉफ्टवेयर डाउनलोड करने के लिए कहा है, ये तो 15 दिन के
जी.
लिए खाली फ्री ऑफर है, उसके बाद इसको परचेज करना पड़ेगा या कहीं आप लखनऊ यूनिवर्सिटी में कहीं अवेलेबल है जहाँ जा सकते हैं?
ये चीज डॉक्टर मसूद सिद्दीकी सर बता पाएंगे कि वेदर द SPSS सॉफ्टवेयर आफ्टर 15 डेज कहाँ से आप कर सकते हैं. वैसे अगर आप थोड़ी सी मेहनत करेंगे तो आप आराम से मिल जाएगा ये सॉफ्टवेयर।
अच्छा ठीक, थैंक यू सर।
जी, इस कुर्सी को छोड़ दूं, ये हटा दूं, बता दूंगा।
So online participants, any other questions if you are having, then please unmute yourself and ask. I think there's no question from the online participants. We can proceed further.
Right, guys. So, in case you have any questions, not today, later on, you can directly email. I'll respond. Give me at least 2 working days to respond. Right? My email ID आकाश से ले लीजिए, मसूद भाई से ले लीजिए. Everybody has it. Or you can directly find it from the website of IFT. It is srastogi@ift.edu. So, in case you have any queries, just send across a mail. Wait for 2 days. नहीं आता तो दोबारा मेल कर दीजिएगा. 99.9% I'll revert to your mails. Right? All the best and happy learning. एक ही है क्या? 2 थे? हैं?